Hi, Chemistry. This is another sample problem coming at you from Chapter 7, Section 3. In this sample problem, we're going to be using molar mass as a conversion factor in order to calculate the mass in grams of 3.04 moles of ammonia vapor, so known as NH3. Okay, one of the first things we want to identify is that we are converting a mole value to a mass value. And so we're going to be going from moles to mass. And we can tell from the fact that these two units, moles and mass, that our conversion factor is going to be, in fact, molar mass. We're going to have some sort of conversion factor that relates grams and moles, and molar mass is the thing that does that. We have grams and moles present at the same time. Again, grams for mass, moles for moles. So we can start by calculating the molar mass of NH3. So hydrogen and nitrogen are present. Using the periodic table to find the average atomic masses of these two species, nitrogen over here, hydrogen over here. I'm going to copy those down onto my paper. Don't try to just simply remember those in your head. Put them on the paper. 14.007. Then you need to take into account how many moles of each of these elements are present in 1 mole of this substance. There are 3 moles, it's supposed to be 9, 3 moles of hydrogen present in 1 mole of ammonia vapor. There is 1 mole of nitrogen present in 1 mole of ammonia vapor. And all that's left for me to do is actually carry out these calculations. Using the calculator, or my calculator, this is 3.0237 grams, and then for nitrogen, I come out with 14.007 grams. Let's sum those. My calculator tells me I'm looking at 17.0307 grams per mole. And this would be the molar mass of NH3 if I had considered the appropriate number of significant figures. Here I have 1, 2, 3, 4 digits past the decimal. Here I have 1, 2, 3. 3 is smaller than 4, so I need to have my answer reported with 3 digits past the decimal point. The 7 is going to indicate that I want to round this up. So the molar mass for NH3 that I'm going to use is going to be 17.031 grams per mole. So now I'm ready to start setting up my crosshairs, my actual conversion. So the problem has me start with 3.04 moles of ammonia. So I go 3.04 moles NH3. Set up my conversion factor. Again, I know I'm using molar mass, so I'll be using both grams and moles. The question is, where do I want moles to be? Well, I know that I'm starting with moles, and I want that to go away because my answer needs to be in grams. So I'll take this moles, and I'll move it down diagonally to the right. Moles NH3. And so all that's left is to place the grams of NH3. Now that I have this set up, I'm simply going to copy these numerical values into my conversion factor. How many grams? 17.031 grams. How many moles? That's per 1 mole. And I'm ready to actually calculate. Notice that the moles of ammonia will cancel. Again, that's why I put moles down in diagonal so that they would cancel, leaving my only unit to be grams, which is what the question is asking for. Notice again that the way I've set up my problem actually tells me what mathematical function to carry out, what to do with my calculator. The way this is set up tells me to take 3.04 and multiply it by 17.031. My calculator tells me that this is 51.77424 grams of NH3. But we're not done yet because we have not considered the proper number of significant figures. I'm using multiplication here, so I need to consider which of these two values that I'm using has the fewest number of significant figures. I see 1, 2, 3, 4, 5 significant figures and 1, 2, 3 significant figures. So my answer can have only 3 significant figures. So I'll round to this place right here. The 7 tells me I want to round up. And so the answer that I will report is going to be 51.8 grams of NaHC.